Dear students, welcome to Module 1 of Design of Machine Elements. This video lecture will be based on Kerala Technological University syllabus. Myself, Harikrishnan C, Assistant Professor, Rajagiri School of Engineering and Technology. Machine design is defined as the use of scientific principles, technical information, and imagination in the description of machine or a mechanical system to perform specific functions with maximum economy and efficiency. A designer uses principles of basic and engineering sciences such as physics, mathematics, statics and dynamics, thermodynamics and heat transfer, vibrations and fluid mechanics. Some of the examples of these principles are Newton's law of motion, D'Alembert's principle, Boyle's and Charles' law of gases, Carnot cycle, and Bernoulli's principle. Overall, design is an innovative and highly iterative process. The basic procedure of machine design consists of a step-by-step approach from given specifications about the functional requirements of a product to complete the description in the form of drawings of the final product. We need to follow a logical sequence of steps. First, we will consider a market survey. Based on that, we will specify the specifications of the product. Then we will be the mechanism. After careful study of the requirements of the designer prepares through rough sketches of different possible mechanism for the product. For example, while designing a blanking or the piercing press, the following mechanisms are possible. A mechanism involving the crank and connecting rod converting the rotary motion of the electric motor into the reciprocating motion of the punch. A mechanism involving nut and screw, which is simple and cheap configuration but having poor efficiency. And the mechanism consisting of a hydraulic cylinder, piston, and valves which are costly configuration but highly efficient. The alternative mechanisms are compared with each other and also with the mechanism of the products that are available in the market. An approximate estimation of the cost of each alternative configuration is made and compared with all the existing product. This will reveal the competitions of the product and you'll be selecting the final configuration. After a proper selection mechanism, we will be preparing the general layout of configuration and selecting joining methods between the individual components of the product. Then we will design the individual components. After that, we will be preparing the assembly and detailed drawing. Then we will be doing the modification of drawings after testing the prototype. This is the complete designing procedure of machine design. We will be following these steps. These steps are interrelated and interdependent, each reflecting and affecting all other steps. These steps are very important when we are fabricating a new product. Coming to the Kerala Technological University Design of Machine Elements syllabus, the first module discussing about the introduction of the fundamental of designing procedures and materials and their properties, and the second module discussing about the theories of failure and the shock and impact loads, and the third module discussing about the threaded joints and the bolted joints, and the fourth module is discussing about design of riveted joints and quarter and knuckle joints and design of welded joints. Fifth module discuss about springs and leaf springs, and the last module discussing about the shafting and designing of coupling. And the course objectives are to review the concepts of statics and strength of materials, to introduce the fundamental approach to failure prevention of components, to provide knowledge in design of common machine elements such as fasteners, shafts, springs, quarter joints, and coupling. These are the course outcomes that we are expecting after completion of this course. And you have to understand and identify some designing methods that is explaining in this slide. These are self-explanatory. The syllabus is prescribing 2 data books, design data book by PSG and K. Mahadevan by CBS Publishers. In our video lectures, we will be following the data books by K. Mahadevan and K. Balavir Reddy, and the contents we are using for our presentation will be from V.B. Bhandari, the Design of Machine Element textbook by McGraw-Hill Book Publishing Company. A machine consists of machine elements. Each part of a machine which has motion with respect to some other part is called machine element. It is important to note that each machine element may consist of several parts which are manufactured separately. For example, a rolling contact bearing is a machine element and is consisting of inner race and outer race. And rolling elements like balls. Machine elements can be classified into two groups: general purpose and special purpose. General purpose machine elements include shafts, coupling, clutches, bearing, springs, gears, and the machine frames. Special purpose machine elements include pistons, valves, or spindles. Special purpose machine elements are used only in certain types of applications. Here, the broad objective of designing a machine element is to ensure that it perseveres its operating capacity during the stipulated service life with minimum manufacturing and operating costs. Just to consider about some of the basic following requirements: strength, rigidity, wear resistance, minimum dimensions and weight, manufacturability, safety, conformance to standards, reliability, maintainability, minimum life cycle cost. These requirements serve as the basics for design projects in many cases. There are mainly two types of designing practices. One is the design by craft evolution. A bullock cart, rowing boat, pillow, and musical instruments are some of the products which are produced by craft evolution process. The salient features of age-old techniques we can describe as: the craftsmen do not prepare dimension drawing of their products. These products are developed by trial and error over many centuries. The essential information of products such as materials, dimensions of part, manufacturing methods, and assembly is transmitted from place to place and time to time by two ways. First, the product, which basically remained unchanged, is the main source of information. The exact memory of the sequence of operations required to make the product is second source of information. There is no symbolic medium to record the design information of the product. Here, these are mainly the weakness. The craft evolution process was successfully developed some of the complex structures. The craft evolution method has become obsolete due to two reasons. This method cannot adapt to sudden changes in requirement. Secondly, the product cannot be manufactured on a mass scale. And so design by drawing evolved. The essential features of design by drawing methods are: the dimensions of the product are specified in advance of its manufacture. The complete manufacturing of the product can be subdivided into separate pieces, which can be made by different people. This division of work is not possible with craft evolution. When the product is to be developed by trial and error, this process is carried out on a drawing board instead of shop floor. The drawing of the product are modified and developed prior to the manufacturing. This carries a lot of design work in design of drawing. In this method, much of intellectual activity is taken away from shop floor and assigned to design engineers. The design procedure in design of machine elements are listed here. First, we need to specify functions. What do you mean by specification of function? The design of machine elements begins with specification of functions. The functions of the machine elements like bearing. It is for to support rotating shaft and confine the motion. If you want to transmit the torque between the shaft and adjoining machine part, you need to design a key. To store and release the energy, you need to design a spring. And if for measuring the force, you need to design a spring balance. To hold two or more machine parts together, you have to design a fastening technique. This is meant by the specification of function. Then we need to determine the forces acting on the body. In many cases, we draw this free body diagram of the force acting on the body, and the external and internal forces act in the machine element are like external force due to energy, power or torque transmitted by machine part, or the static force due to the dead weight of the machine part, or force due to the frictional resistance, inertia force, centrifugal force, or the force due to the thermal gradient, or the force set up during the manufacturing part resulting the residual stresses, etc. that we need to take the consideration. Then selection of materials. For four basic factors which are considered in selecting the material are availability, cost, mechanical properties, and manufacturing considerations. Consider the designing of a flywheel or housing of gearbox or engine block. These have complex shapes. These components are made of cast iron. Because of the casting process produces complicated shapes without involving any machining operations. So we need to design these fundamental factors: availability, cost, mechanical factors, and manufacturing considerations. We will select the material. Then we will go with the failure criterion. Then the failure criterion, then the machine component is said to have failed when it is unable to perform its functions satisfactorily. The three basic types of failures are failure by elastic deflection, failure by general yielding, and failure by fracture. And we have to design the determination of dimensions. Here we have to shape the shape of the machine element depend upon two factors: the operating conditions and the shape of the adjoining machining elements. For example, invalid profile is used for gear teeth because it satisfies the fundamental of gearing. A V-belt has a trapezoidal cross-section because it results in wedge action and increases the force of friction between the surface. So this factor is also important. Then after the selection parts, we will modify the designs. The geometric dimensions of the machining elements are modified from assembly and manufacturing considerations. For example, the transmission shaft is provided with steps and shoulders for proper mounting of gear and bearings. Revised calculations we can carry it out for operating capacity, margin of safety at critical cross sections, and we can modify the design. Then it moves to the working drawing, the last step of the design of machine elements. We need to prepare a working drawing of the machine elements showing the dimensions, tolerances, surface finish, grades, geometric tolerances, and special production requirements like heat treatment, etc. It's defined as the process of creating or selecting configurations, materials, shapes, and dimensions for a product. This is decision-making process with the main objective of optimization. There is a basic difference between the design analysis and design synthesis. In design analysis, the designer assumes a particular mechanism, a particular material, and the mode of failure for the component. With the help of this information, he determines the dimensions of the product. However, design synthesis does not permit such assumptions. Here, the designer selects the optimum configuration from a number of alternative solutions. He decides the material for component from the number of alternative materials. He determines the minimum shape and dimensions of the component on the basis of mathematical analysis. In design synthesis, the designer has to fix the objective. The objective can be minimum cost, minimum weight or volume, maximum reliability or maximum life. The second step is mathematical formulation of these objectives and requirements. The final step is mathematical analysis for optimization and interpretation of the results. Just consider the case of design synthesis of designing of a cylindrical can as a synthesis method. First, the requirements are the cylindrical can is completely enclosed and the cost of the material should be minimum. The cans are to be stored on a shelf and the dimensions of the shelf are such that the radius of can should not exceed R max. To optimum conditions or to find optimum radius, we will be formulating a mathematical relations connecting to area, and we will differentiate, or we will optimize the radius using the area differentiating steps. We will be optimizing the radius and we will conclude in a final radius value. The design synthesis begins with the statement of requirements, which are then converted to mathematical expressions, and finally the equations are solved for the optimization. This is the basic procedure of design synthesis. So with this, we will be concluding the video 1, the first video of this. We will be continuing this module with more videos. Stay tuned. Thank you.